I received a question about Module 7, problem number 6. So I'm going to walk through how to do it, just to give you guys a little idea of how to do all the different steps in StatCrunch. So please, I'm just also going to ask you to forgive me if I have to take a break or drink water. I've got tonsillitis, so I'm going to do the best I can here. A doctor wanted to determine whether there is a relationship between a male's age and his HDL, so-called good cholesterol. The doctor randomly selected 17 of his patients and determined their HDL cholesterol. The data obtained by the doctor is the data table below. Complete parts A through F below. So let's look at part A. Draw a scatter diagram of the data treating age as the explanatory variable. What type of relation, if any, appears to exist between age and HDL cholesterol? So let's go ahead and do our scatter diagram. We're going to click on our data set and then click on the icon to open it in StatCrunch. So to do our scatter diagram like I did in the videos a little bit earlier this week, we're going to go to graph and scatter plot. We're going to select our X variable, which is age, and our Y variable, which is HDL cholesterol. Remember, because we're using age as a predictor for HDL cholesterol. So you see here, it doesn't really look like there's a pattern. It's pretty much all over the place. If you saw it in a kind of a grouping in this way or a grouping in this way, or even like a U shape, there would be some kind of pattern, but in this case, we don't see a pattern. So we're going to say there does not appear to be a relation. Good job. All right, next. Determine the least squares regression line equation from the data set, from the sample data, excuse me. So remember, even though we don't see a pattern here, we can still find a regression line. It just may not be a good fit for our data. So let's go ahead and go to Stat, Regression, Simple Linear. We're going to select our X variable and our Y variable again, just to get our regression line, and we're going to click Compute. Make that a little bit bigger. So as you can see here, we need to round to 3 decimal places. So our equation, we have it in 2 places. We have right here, but we can also get those coefficients from right here. So we have basically Y equals, and I always like to put the X coefficient first. That's just how I have always done it. So negative 0.122 X plus 50.833. All right, let's plug that in to check our number. Negative 0.122 and 50.833. Check answer. Fantastic. Are there, part C, are there any outliers or influential observations? Now, let's look back at our graph and let's look at a common sense way to look at outliers. Do we see any X values that are extremely out of the range? Like, for example, age equal to 80 or age equal to 3, for example. Those would be something that would be an outlier that if we were to remove it, we would then see a more linear, or maybe non-linear, but a pattern in the data. From what I'm looking at, I don't see anything that's significantly impacting the data, like 1 or 2 outliers that if we were to take them away would give us a good pattern. So we're going to say there's no outliers. Check. Fantastic. All right. Assuming the residuals are normally distributed, test whether a linear relation exists between age and HDL cholesterol levels at the alpha equals 0.01 level of significance. So what are the null and alternative hypotheses? Now in this case, they're just asking for if there's any linear relation, not positive or negative. So if they were looking at positive or negative, we would be looking at these less than or greater than or less than 0. But in our case, we're just looking for the null hypothesis is equal to 0, and the alternative would be not equal to 0. That's it's either positive or negative linear relation. Well done. Okay, use technology to compute the p-value. Use the tech help button for further. So, well, let's just go to our My Stat Lab again. I'm going to get out of the graph. But again, remember I said this in one of my previous videos. If you go up here to StatCrunch and results, you can go back and look at your old results that you've closed out. So we're going to go to stat again, and I'm just going to go through the process again. Simple linear, select our x and our y variable, and we're performing a hypothesis test. As you can see here, it's already set up to intercept equal to 0, and intercept does not equal to 0. Excuse me, does not equal 0. Remember, if we were looking for a positive or negative linear relationship, we would be looking at one of these. So let's click compute. And we see here, where is our p-value? Right there. P-value is right there. So we have 3 decimal places. So it's going to be 0.567. Let's plug that into check. Check answer. Well done. Okay, so next, what conclusion can be drawn at the alpha equals 0.01 level of significance? Remember, if your p-value is less than alpha, then you reject the null hypothesis. If your p-value is greater than your alpha, then you do not reject the null hypothesis. So in this case, our p-value is 0.567, which is clearly larger than 0.01, our alpha. So we do not reject the null hypothesis because the p-value is greater than alpha equals 0.01. Let's check our answer. Excellent. Now, let's just talk a little bit about what that means. That probably means that there's no linear relationship. So even though we built a linear model, it's not necessarily appropriate for this data set. And that has, just let's think about this logically too, looking at age and cholesterol. You will probably see more of a correlation in cholesterol with something like the certain types of foods that you might eat or level of exercise than age. You can have a very young person who doesn't eat very well, who has high cholesterol. You can have someone who's older, who exercises regularly and eats very well. They're going to have low cholesterol. So let's just to put that in more of like a logical, let's think about this perspective so that it helps us better understand the numbers we're looking at. So part E, assuming the residuals are normally distributed, construct a 95% confidence interval about the slope and the true least squares regression line. So let's go back to StatCrunch. I'm going to close out of this and go through the process again just to kind of show you guys. We're going to go stat, regression, simple linear. We're going to select X and our Y variable. And this time we're going to check confidence interval. Now it said for a 95% level of confidence, which is already there as the default. So we can leave that alone. Click compute. And we are looking for the confidence interval of the slope, and that would be right here. So you see we have slope, and there's our confidence up. So our lower limit is right here, and it said to round to 3 decimal places. So we're going to have negative 0.564 and 0.321. So let's put those into check. Negative 0.564 and 0.321. Check answer. Good job. All right, let's look at the next part. For a 42-year-old male patient who visits the doctor's office, would using the least squares the least squares regression line obtained in part B to predict the HDL cholesterol of this patient be recommended? And it even gives you a little note here, and this is kind of what we talked about. If the null hypothesis was rejected, that means that the least squares regression line can accurately predict the HDL cholesterol of a patient. If the null hypothesis was not rejected, that means the least squares regression line cannot accurately predict the HDL cholesterol of a patient. Recall from up here in parts, I guess that's part D, we did not reject the null hypothesis. So let's go back down, click continue. Should the least squares regression line be used to predict the patient's HDL cholesterol? Choose the correct answer below. No, because the null hypothesis was not rejected. Check answer. Good job. All right, the last part of this is a good estimate for the HDL cholesterol of this patient is the mean of the data set. Since we can't rely on that linear model, the best thing that we can do to estimate would just be look at the mean. So let's go to stats, summary stats, and column. Select our Y variable because we're looking at the mean of the cholesterol as our best prediction. And in this case, we have 45, what does it say? 2 decimal places. So 45.35. 45.35. Let's check our answer. Fantastic. So that's how you do number 6. And I think if you're having some problems with some of the other problems in the assignment, this might help you because this went through several steps in the linear regression, both how to read the scatter diagram, how to generate it, how to look at the find the least square regression line, how to do a hypothesis test on the slope. So I hope this helps you guys. If you have any questions, let me know. And anything else on any other modules up until now, or even about the review for the final that we're going to be doing next week. Hope you guys have a good day. Thank you.